Hi, back again for lesson 2. This one is going to be on the first trend that we talk about in the periodic table, which is the atomic radius. We learned in the last lesson that the effective nuclear charge changes as we go across a period or down a column, and that's what will cause the changes in the atomic radius. But how do you measure atomic radius? An atom's mostly empty space. There's just a lot of electrons buzzing around this nucleus, but there's no clear-cut boundary. So the way that it's measured is by measuring half the distance between the nuclei of two like atoms. Here you see two chlorine atoms, and half of the distance between their nuclei is measured in picometers. Picometer is only 1 times 10 to the negative 12th of a meter. That's extremely small. That is 1/1000th of 1/1,000,000th of a meter. Here you see the diatomic elements, and these are always occur in pairs of 2 anyway, so it's a little bit easier to use these as an example. And here's some of their atomic radii. So the first trend, going down a group. This one is a bit easier to understand because it's kind of makes sense that as you go down a group in the periodic table, there's more and more energy levels. There's also more and more electrons. So it stands to reason that the radius is going to get larger. Here you see magnesium and barium. These are both group 2 metals. And magnesium has 3 energy levels, whereas barium has several more. There's a lot more electrons here in barium. And so it's a larger atom. But going across a period in a periodic table, that's not quite as intuitive. You might think that the radius is going to increase because you are adding more electrons as you add more protons. But you need to keep in mind that all the elements in the same period have exactly the same amount of shielding. They all have the same number of core electrons. So here you see magnesium and chlorine. These are both period 3 elements. Chlorine does have more protons than magnesium. It does have a stronger nuclear charge, but they both have the same shielding, 10 electrons. This chart shows you the relative radius of the atoms on the periodic table, and if you just remember that helium is the smallest, then you'll always remember that the trend goes smallest to the right and smaller up on the top. And here is a graph of the atomic radius versus atomic number, and we talked about the periodic law saying that these properties are functions of their atomic number, as you can see here. In this graph, notice that on the top are all of the group 1 metals. And the group 1 metals, if you look down here, it starts with lithium, goes to neon, so this is the period 2 elements, and here we have period 3 elements, and here's the first appearance of the D block right over here from potassium to krypton. Ion formation. This also is something to keep in mind. So the radius of ions is not the same as the radius of their neutral atoms. In cation formation, ions lose electrons. So these are the metal atoms. They lose electrons. That means their electrons cloud is going to decrease. It gets smaller. With anion formation, the nonmetals gain electrons. And when they gain electrons, there's going to be not only more electrons, but more negative repulsions, and that electron cloud will get larger. So anions are larger than their neutral atoms. Next, we'll look at how the ionization energy of the elements differ based on their effective nuclear charge.